GM everyone, and welcome back to another installment of the Secret Network CosmWasm Developer Bootcamp. In the previous video, you learned how to make a full stack application with access to secret network randomness. And in this video, you're going to learn how to deploy your very own confidential token on Secret Network Testnet. So a unique feature to Secret Network is the ability to have privacy preserving tokens where you can send a token to somebody else on the network and all the details of that transaction will remain veiled. And in today's lesson, you're going to learn how to deploy your very own private token on Secret Network. So to get started, I want to just walk us through the docs and also show you actually what we're going to be building on the Secret Network dashboard. And then we're going to clone down some code to our machine locally and get started building. Private tokens on Secret Network are called SNP-20s, and every token on Secret Network can have a privacy preserving counterpart, which is the SNP version of that token. For example, other protocols like Shade, CeFi, Alter, ETH, BNB, Atom, they all have wrapped tokens on Secret where those transactions can remain private. So Secret has a token called Secret, but it also has a wrapped version of the token called Secret, or S-Secret for short. And whenever you make a transaction with Secret, it stays private. A really good way to think about this, here's an example of SNP-20 privacy from the docs. So if a wallet A sends 100 Secret to wallet B, this is what will happen. The block explorer denotes that wallet A interacted with the Secret smart contract, but it's not known what it actually did. It doesn't know if it was a send, a buy, an NFT, a creation of a viewing key. The amount of tokens is also unknown. And then wallet B will not have any interaction listed on chain on the block explorer. And then wallet B can use their viewing key to decrypt the receiving transaction, see the address of the sender, and also the amount that they received. But on chain, on the explorer, for everybody else involved, all of that remains encrypted in transit. So that's what we're going to be learning how to build today. Here's an actual example of what that looks like. This is on the Secret Network dashboard. You can actually use the dashboard to wrap tokens into their privacy preserving counterparts. So for example, I can wrap the standard Secret token into the Secret token. Let's just do that so you see what that looks like. So I'm going to wrap Secret to Secret. I'm just going to wrap one. I'm going to request a fee grant to pay for gas, and then I'm going to execute that wrap. All right, so previously I had 78.5 Secret. The transaction is currently wrapping one of my Secret tokens into a Secret token, and then I should have 79.5 tokens. So let's just refresh. Oh, there you go. I just saw it. Now I have 79.5. And you'll see there's all these other tokens that you can do this for, such as Tether, USDC, ETH, Atom, Juno, Arch, Akash, etc. If you want to learn more about the SNP-20 spec, about these private fungible tokens, you can do so by navigating to the Secret Foundation SNP's SNP-20 page. I'll link that in the YouTube description below. In this, you'll learn some of the basic functionalities of working with SNP-20 tokens. It's built and loosely designed around Ethereum's ERC20 standards, and it's a superset of CosmWasm's CW20. So if you've worked with ERC20s or CW20s before, some of this should look familiar. There's some standard message types like transfer, send, register, receive, creating a viewing key, setting a viewing key. This is something that's specific to SNP-20s, and we'll learn how to do this today to actually interact with our own SNP-20 that we create. And then you can also query balances and token info, etc. There's a lot of other messages and message types and query types. I'll let you browse that on your own time. Today, I just want to teach you how to launch your own token on Secret Network Testnet. I'm going to be working from this page of Secret Network's documentation called Secret Tokens SNP-20, which is underneath the Secret Contracts tab in development. First, what I'm going to do is just use the source code here, and I'm going to clone it to my machine locally. CD into desktop, and then just git clone the SNP-20 reference repo. And this is what you're actually going to be uploading to Secret Network Testnet today. So I'm going to open up my text editor. and open up that repository. And before we actually compile this contract code, let's just take a look at some of the message types so you understand what we're going to be looking at. All right, so I opened up message.rs. I always like to open up message.rs when I start looking at a smart contract, because that's where all of the actions you can actually take happen. You can kind of just get an understanding, a good feel for what the contract is actually doing. In this instance, we can see that we have an instantiate message that's pretty hefty. We have a name for our token, an admin, which is optional, a symbol for the token, so like secret or whatever you want to make it, decimals and initial balances, a randomness seed, an optional configuration parameter, supported denoms. So as you see, a lot of this is optional. Like for example, this config parameter, let's just take a look at what that actually is. So these are additional optional values that we can instantiate the smart contract with, like a total supply is just a bool, so true or false. Enabling deposits is true or false. Enabling redemption, so whether redeem functionality should be enabled, minting functionality, burning functionality, the ability to modify denominations. And then here we see all of our execute messages. So there's redeem, deposit, transfer, which should look familiar if you've worked with ERC20 tokens before, send. So just a quick distinction working with CW20s. Transfer is what you use to send tokens to another wallet address. Send is what you use to send tokens to a smart contract address. And then you can send tokens in batches. You can burn tokens. You can create viewing keys. You can increase the allowance, so the amount that like a smart contract can actually spend on your behalf. Lots and lots of messages. Let's just compile this code though, and then learn how to actually upload our own token to the blockchain. So to compile the code, I'm going to run a script in this make file, which is just make build mainnet reproducible, which should create an optimized WASM file that we can then upload to the blockchain. All right, awesome. So our contract is finished compiling and it has been saved in this optimized WASM folder. You can see our snip20 reference implementation.wasm.gz. That's the compiled contract code. Now let's upload that to the blockchain. So I'm going to cd into our node folder and I'm going to install the dependencies. I'm actually going to uninstall secret.js and then reinstall it real quick, because if we look at this here, we have an outdated version. So I just want to install the most up-to-date version of secret.js, which is the JavaScript SDK that we're using to upload and execute our smart contract and query our smart contract. All right, so now we're working with secret.js 1.15.1. Let's take a look at this upload script. So here I have a wallet hard-coded. This is just a wallet that already comes pre-funded with secret testnet tokens. But if you wanted to use your own secret testnet wallet address, you could just plug and play, put that mnemonic in here. I always use a testnet wallet for working with testnet tokens. I don't like to conflate my mainnet and testnet wallet addresses, because it's very easy for your mnemonic to get leaked this way if you ever push this to GitHub. So just be very careful with this. But this is just an address that is pre-funded with secret testnet tokens. If you've never done that before and you want to learn how, I'll just teach you really quickly. You can just search secret testnet faucet. There's a network faucet here, and then you can just paste in your secret wallet address from Kepler. So this is my testnet wallet address. You can see I already have testnet tokens. I can copy my address, paste it in, prove I'm not a robot, and then it will send 100 testnet tokens to my wallet. Okay, and here in our code, we're just reading the WASM file that we just compiled. So we see that that's in that optimized WASM folder, and it's referencing the snip20 reference implementation.wasm.gz file. And we're going to do this on Secret Network Testnet, which is why we are using the Pulsar 3 chain ID and the URL api.pulsar3.secrettestnet.com. Were we to do this on mainnet, if you wanted to launch a token on mainnet right now, all that you would have to change to do that is just the chain ID and the chain URL. So if we go back to the docs and we go to the API endpoints here, connecting to the network, API endpoints for mainnet. So currently we have the LCD API endpoint for testnet. All you have to do is just update this for mainnet and update the chain ID to be for secret 4 instead of pulsar 3. And then voila, you would be instantiating your SNP20 token on mainnet. So this should look familiar by now if you've been following along with the developer tutorials. We already have an upload and instantiate script written out for us. Before we instantiate this, just look at the instantiation script. Upload should look exactly the same. We just use secret.js with this store code method, and we have a sender and we have the wasm bytecode. Instantiate is going to look a little bit different though, because this is where we are actually writing the name of our contract address. So something to note, let's make our token name. Let's just call it, I'm going to call it tutorial. And our symbol will be toot, and toot for tutorial. We're going to make the decimals 6, because if we make it 6 decimals, then it will be paired 1-to-1 with a secret token, which is what we want. You could make it less or more though, completely up to you. Like if you wanted to make like a Doge type coin, you can make it, infinitely more. PRNG seed, this is just where we instantiate it with randomness. So that's what this is right here. Admin is my wallet address, and then the initial balance, this is how many tokens it's going to start with. So my wallet address will start with this amount of the toot token. I'm also instantiating it with that optional config parameter that we just looked at. So you see that I have enabled deposit as true, redeem as true, mint true, everything's true. So I instantiated with that additional configuration parameter. Ignore this. This is called the tutorial meme coin. All right, and I think that's all we need to create our contract. So let's do it. And then I'll show you how we can actually view and add this token on Kepler after we do this. So I'm going to run node upload to run this node upload script. It returns a code ID, a contract hash, and it should also return a contract address if we did our instantiation correctly. Incredible. And then we can actually query that contract info. So I already wrote this query script for you. Let's do that. So let's update the contract address and the contract code hash here. All right. And then we use this query contract method where we input the contract address, and then the name of the query is token info. So if we go back to the messages, we can actually see that this is one of the query types. Let's just look at that so you understand everything we're doing. See, token info right here. And we could just replace the name of this query message if we wanted to do another query type. So first we're going to look at token info. So I'm going to run this query. And the way we do that is node query token info.js. Okay, and it returns the token info. So we have the name of the token, tutorial, the symbol, toot, the decimals 6, total supply is null, I guess because we didn't include that in our configuration parameter. All right, so now you've seen this token info query. Hopefully you understand how you could additionally do any of these other queries. You just have to write the snake case version and then just pass the correct parameters. So we've queried that our token was instantiated successfully. Now let's actually send that token in our Kepler wallet. So this is how you add a SNP20 token to your Keplr wallet. I'm just going to copy the contract address for the token. I'm going to go back to Keplr. I'm in my test wallet here. I'm going to say add token, and then scroll down to secret testnet, add token, paste that contract address. It auto populates. Say confirm. It's going to set a viewing key for our wallet so that we can then have a viewing key that allows us to actually view how much of this token we own. I'm going to approve that transaction. Okay, there we go. And now we see that we have 1,000 of this token because this is the wallet address that I instantiated the contract with and said that that's what I wanted the starting balance to be. Let's just send some of this to my other wallet just for fun. So like currently in this wallet, I have 0 of that token, right? All right, so you see I went from 1,000 to 900 of my 2 token. And then if I go back to this wallet address, I should now have 100. Awesome. And now we see that I have 100 of my secret toot token here. Let's do one more query just for fun. Let's do this balance query that takes an address and a key. So we need the correct viewing key in order to query the balance. All right, so I'm going to update the query to be for balance. And then balance takes an address as well as a key. So this should fail because it's not the correct viewing key, right? Let's just run this query just to see that. Wrong viewing key for this address or viewing key not set. Now, if I go back to that wallet address, and here's how you view your viewing key in Keplr. So I'm back in the wallet address that instantiated the contract. Now I'm going to go to add token, back to secret network testnet. Here, I can copy my viewing key. Okay, so I'm going to copy that viewing key and then replace this with the viewing key that was created by my Keplr wallet. Now let's try this again. And there you see it. I have 9,000, or I have 900 of this token. All right, everybody. Thank you so much for watching today's Secret Network CosmWasm Developer Bootcamp. Today, you learned how to upload, instantiate, and configure your own SNP20 token on Secret Network Testnet. And you also have all the tools you need to be able to deploy your own contract to mainnet, should you choose. I hope you get out there, start deploying your own meme tokens or whatever you want. And if you have any questions, just message me or anyone in the Secret Network community in the Secret Network Community Developer Telegram group, which I'll make sure to link in the chat below. Thanks so much for watching, everybody. Be sure to like and subscribe, and I'll see you on the next developer video.